All right, today's lesson, lesson 10.5, we are talking about inscribed angles and polygons, okay? So here's the definition of an inscribed angle. It's an angle whose vertex is on the circle, whose sides contain chords. So it's actually inscribed, it's inside. The sides contain chords of the circle. The measure of an inscribed angle is half the measure of the intercepted arc. Right, if I can, like, in this first circle here, I'm going to call it number 1, okay? So this is an inscribed angle. The vertex, sorry, my pen just went crazy, touches the inside of the circle, right? And now it separates, these are two chords. It kind of looks like a Pac-Man, okay? So if you see that this out here is 60 degrees, we divide by 2, and we get 30 for the inscribed angle. So it's half the measure of the intercepted arc. The intercepted arc is this portion of the circle right here, okay? And you can see the definition for that. So first off, let's look at our example number 2 here. All right, so here's my second example. Here, it's saying that this minor arc is 70 degrees, okay? The circle center is C. This is a central angle, which is the same. Remember, that's like the projector. Whatever's in the center projects out to the edge of the circle. But inscribed, when I go inside the circle, things change a little bit. I need to divide by 2 to get in here. So from this arc all the way inside, I divide by 2, and we get 76 divided by 2. What's that, 39? So this is 39 degrees in here. So remember, this central angle is the same. Inscribed is half the measure of that arc. So if you look at this third example I have, number 3 here. I like to change colors because I can, you know. All right, so now I have this inscribed angle is 25. When I go out to the arc measure, I multiply by 2. Well, 2 times 25 is 50. So this arc, AB, is now 50 degrees. It's twice the measure of the inscribed angle. Hopefully that made a little bit of sense. Just remember, central angles are the same, right? So that means if I were to put a mark for this angle, what would the measure be for that angle if it's the same as that arc? This would also be 50 degrees here. Hopefully that helps a little bit. Alrighty. Now we're going to talk about inscribed polygons. Okay, so, I'm just kidding. Here's another theorem. If 2 inscribed angles of a circle intercept the same arc, I'm going to use my highlighter and show you what I'm talking about. Here I have an inscribed angle. Okay? It intersected the arc AB. I also have another inscribed angle right here, which intersects the same arc. This arc AB has been intersected by both of those, the one in orange and the one in blue. That means those angles are congruent. So we can go ahead and use our little fancy mark to show that those angles are congruent in there. So for me, sometimes it helps for me to draw with the pencil. I don't know if you have any colored pencils or crayons to see that they're intercepting the same arc so that you know that those angles are congruent. All right, inscribed polygon. I'm sorry, I jumped forward earlier, but here we are. That's what I want to talk about. It is a polygon where the vertices all lie on the circle, meaning the points are all on the circle, inside the circle, okay? So those are polygons. This is also an inscribed quadrilateral, right? It's got 4 vertices that are all on the circle. Circumscribed circle is a circle that goes around the polygon. So my red circles are circumscribed circles. They go around the polygon. All right, so now we're going to do some practice problems. We can do that, okay? So first off, I want to know what the measure of the minor arc BC is. That's right here. Notice its opposite of my inscribed angle. So inscribed angles are, from here, from the arc, we divide by 2, but if we have the angle, we multiply by 2. So 40 times 2 is 80, right? This is 80 degrees. All right, now we need to find the measure of the angle BCA. BCA, I'm going to highlight again. BCA, I'm looking for this angle in here. This angle right in here. Now, you know that this box, this is 90 degrees, so this is 90 here, and we have 40. Well, 40 and 90 is 130. It's a triangle. A triangle is 180 minus 130 gives me 50 degrees. So that's 50 degrees. Let me see if I can erase this without damaging. Oh, sorry. Oops, I went too far. Uh-oh, I'm sorry. All right, I'm just gonna, we already know that BC was 80 degrees, okay? And then we said that the angle BCA was 50 degrees. I'm gonna put a little 50 degrees in here, and that's gonna make me happy. All right, now I'm looking for the arc AB. This is a minor arc AB. Let's trace again. Okay. I'm looking for this arc. Do you see that the vertices of that circle, that circumscribed circle, intersect that arc? Okay, so that's an inscribed angle too, right? Each of the corners touch the side of the circle and goes all the way in. So we divide by 2 to come inside. So we multiply by 2 to go out. So times 2. Well, 50 times 2 is 100. The measure of that arc is 100 degrees. All right, now we have a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So that means opposite on the diagonal, right? That means this plus that must equal 180. Well, 180 minus 120 is 60 degrees. So this is 60 degrees up here. When I go the other way, I have 80 here. 80 and this angle here at x must be 180. They must be supplementary. So 180 minus 80 gives me 100. So this is 100 degrees here. All right, and then here's where we have some crazy variables, so don't worry. All we know is the angles on a diagonal must be supplementary. So that means 18y plus 126 equals 180. Subtract 126 from both sides, and I have 18y is equal to 54. Divide by 18, y is equal to 3. Okay, now I need to go the other way and solve for x, okay? Because I know that 18x plus 72 equals 180. 18x plus 72 equals 180. Subtract 72 from both sides. 18x equals 108. Divide by 18. And I have x is equal to 6. Hallelujah. All right, that's no problem. We don't even need to plug it back in. That's pretty cool. Let's look at some more practice problems, okay? Oh, here we have that double inscribed. Look at this arc. This arc here from BC it's inscribed from both this measure and, I'm trying to use different colors so you can see, and this inscribed angle. Both of those intercept the same arc. So that means the angles in here are congruent. So that would tell me that this in here is 38 degrees. Okay, it's an inscribed angle. That means we times 2 to find the measure of the arc. 38 times 2 is 76. So this green part of my circle is 76 degrees. So now I can answer my questions, right? I know that the arc BC is 76 degrees. I know the angle CCA CDB, which was missing, we know it's 38. All right, number 2, here I have that the angle, the arc, the minor arc here, MP, is 88 degrees. When we go to the inscribed, all the way to the other side of the circle, we divide by 2. Divide by 2. 88 divided by 2 is 44. That means the measure of MNP is 44 degrees. All right, we got a couple more to get through here. So it tells us that BC is the diameter. What does a diameter do? It makes a semicircle. So I know that this whole area out here is 180, okay? This whole thing is 180. I also know, if I go the other way, that this whole thing is 180 as well. Well, looky here. If you see that this inscribed angle intersects that arc that I know is 180, I just take 180 divided by 2, and I will get the measure of x, which is 90. So this is 90 degrees in here, because it's half of this intercepted arc. So x is 90 degrees. Now I have a triangle. I know it's 180 inside, so 180 minus 90 minus 20 is 70. So y is 70 degrees. Okay, so now we got to find x, okay? Let's try to I want you to try to draw these pictures as best you can. I know if you don't have this paper in front of you, it's really tricky. But the notes are all available in a folder on Schoology if you want to print them out and then come back to the video. So here, that arc intercepted BC. Do you see that? Now if I go the other way, this inscribed angle, I'm sorry, I said arc, I meant angle. This angle also intercepts BC. So that tells us that the two arcs right here are congruent. Well, x is 50. If we look at the other direction here, this is where things get really weird and people get frustrated. If we go the other way, okay, that angle intercepted the minor arc AD, and this angle also intercepts that same arc, so that means those angles are congruent. Maybe you don't think it's cool, but I think it's pretty cool. So if this one's 30, then that is also 30. Oh, and I forgot my degree sign. Sorry, guys. All right, we only have 2 more examples to go, or maybe just 1. Oh, nope, there's 2. All right. Oh my gosh, this is the one that I was afraid of, and I don't know why when I was looking through it, I was like, oh my gosh, it's going to be terrible. But remember, an inscribed quadrilateral has diagonal angles that are supplementary. So I can solve for x and y pretty easy because I know together they equal 180. So 180 minus 77 is going to give us x, which is 103 degrees. Now I'm going to go the other way. Now I know that 110 plus y equals 180, so just take 180 minus 110, and that gives us 70 degrees. That's the measure of y. Cool beans, cool beans, cool beans. Please note that this 90 degrees is talking about this portion of the circle. That is 98 degrees. We need to figure out the rest. So what we're going to do is I'm going to use my fancy highlighter, and hopefully we can figure that out. Because I'm going to be highlighting the heck out of this damn boy here. So first off, this angle here. So all of this is more than just W. All of that is twice 77 degrees. So twice 77, let me get my little fancy calculator on here. 77 times 2 is 154. I'm just going to make a note of that. This green line is 154 degrees. Oh, not 1,540. I don't know why I wrote that. Okay, now let's keep going with our inscribed angles all the way around the circle. Actually, what I also am going to do is I'm going to fill out what x is. This is 103, and y is 70. All right. Let's go the other direction, completely opposite here. We're going to I'll use orange. So here's an inscribed angle. It intersects the arc, IC, and including the blue, okay? So that whole orange is 2 times 103. So this whole orange part of the circle is actually 206 degrees, okay? We know this blue arc is 98. We can subtract and find z. So 206 minus 98 will give us the measure of z, which is 108. So z is 108 degrees. All right, the only one we're missing is WF. So let's do one more inscribed angle and see if we can't find our overlap. Let's put that this is 108, so we have it here, that portion of the circle, that minor arc there is 108. And change color so we can kind of separate what we're looking at here. All right, which way did I not go? Because we're looking for a W. All right, here it is. Okay, now it looks like I have a brown line. But do you see that this arc is all of this measure here of the circle? So, what's happening here? All right, now that brown line I just drew, it intercepts this arc. I'm gonna use gray and try to see if that works. So do you notice it overlaps at 108 and it encompasses that W that we're looking for. So now W plus 108 is twice of 110. Twice 110, or 2 times 110 is 220. So we just got to take 220 minus that part of the arc that we don't need, so minus 108. That will give us, oh, why did I write 180? I don't know, because I'm weird. All right, so 220 minus that 108 minus the overlap is 154. And that's not right. What am I talking crazy talk? What's happening here? Please forgive me. Please forgive me. I have to get my calculator out. I'm losing my mind. 220. Oh, what's the end of the day? I'm doing my best here. 112. All right. Let's see if we got this right. I just want to quick double check and make sure that all the way around my circle is 360, that I didn't accidentally go berserkowitz and mess up something here. So 108 plus 98 plus 154. Yay, I got it. All right. Yay, it is it. It is it. It is it. This is it. All right, so it's tough. So, yeah, I would recommend getting colored pencils or highlighters to try to see, like, so you have to, like, kind of solve more information around the circle than you need, and then subtract your overlaps areas. All right, let's see what else we got here. Oh, my goodness gracious. I see X's, I see Y's. Guess what's going to happen here? We're going to have a system of equations. So what we need to do is remember that the diagonal angles are supplementary. So on the diagonal, I add them together, 10y plus 40x equals 180. Now I'm going to go the other way. All right, 19y plus 22x equals 180. Woohoo! All right, here's what we need to do. This is a system of equations, right? I have 2 equations with 2 variables. I'm going to use the elimination method. I am going to choose to eliminate y. Okay, in order to eliminate, I need the variable or the coefficients out front to be opposite of the same number, right? I need one to be positive and one to be negative, so when I add them together, they go away. So first, I'm going to take this first equation and I'm going to multiply it times 19. I'm going to multiply every term by 19. And that's going to give me 760x, I mean 700, no, oh. My paper, I have my x term first. So it's going to give me 190y plus 760x equals 19 times 180 is 3,420. All right, now I'm going to multiply the second equation by what? What's going to give me the opposite for my y? Negative 10. I need the signs to be opposite. So, negative 10 times 19 is negative 190. Now I have my opposite coefficients, right? Negative 10 times 22 is negative 220x. And negative 10 times 180 is negative 1,800, okay? I'm going to add these two together. Woo-hoo! And we're going to eliminate. Isn't it so much fun? Aren't you so excited? All right, maybe not. Maybe not as excited as me, but let me see what we got going on here. And I just want to make sure my calculations are correct. I'm going to add 760 and negative 220. That gives me 540x. Then 3,420 plus negative 1,800 is 1,620. So we're going to divide by this 540. And it's going to give us x is equal to 3. Whew, that was crazy. But we ain't done yet, boys and girls. We got to plug it back in because we got to find y. I'm going to use this top equation. So 10y plus 40 times x, which is 3, equals 180. 10y plus 120 equals 180. Subtract 120, and I get 10y is equal to 60. Divide by 10, y is equal to 6. Whew, there we go. See, that wasn't too bad. It's not too bad plugging it in, but it's definitely tricky when you're trying to remember how to solve a system of equations. If you need to rewatch this video, please do so, because this is the most complicated part of Chapter 10, the last chapter. All right, and here's your assignment for today. I do not think it's assignment 54. I actually think it's assignment 53. I'm losing track at this time. It's coming down to the end of the year, so I'm getting a little bit busy. So let's just call this 53 for now. All right. Yes, it looks beastly, but you need to practice. So there are 3 different pages. There's only 3 problems here. There's only 3 problems there. There aren't that many on the first set. So make sure you complete those. Please send me a message on Schoology if you have any questions. I'm here for you. And have a great day. I'll talk to you later. Bye.